Okay, for activity number 3, we have the Newton's second law of motion. Okay, for activity number 3, okay, according to the definition of the Newton's second law of motion states that the acceleration is directly proportional to the force and inversely proportional to the mass. That is the reason we have force is equal to mass times the acceleration. Although in your thermodynamics, you're going to use your force is equal to mass times the acceleration over k, where k is a force constant. This one is used only to convert your kilogram force into Newton or gram force into a gram force into dyne. Okay. Although here we're going to use force is equal to mass times the acceleration. Now, for the objective, you have to investigate the relationship existing between the force, mass, and acceleration. Number 2, to examine that the acceleration is directly proportional to the force, assuming mass is kept constant. Number 3, to examine that the acceleration is inversely proportional to the mass, assuming force is kept constant. Now, what are the apparatus? We have the weight, hanger, plane with pulley, meter stick, dynamic cart, stopwatch, string, and slatted weights. We have the procedure, constant mass with varying force. Number 1, set up the experiment as shown in the given illustration, which was given to you. Then, to counteract the friction, add small mass of 10 grams to the hanger to allow the cart to move with uniform speed. Do not remove the small mass in the next part of the procedure. Number 3, place a 20-gram weight on a hanger. Then the fourth one, vary the accelerating force by adding slotted masses. And fifth, repeat the step for 3 trials. Now, for the data and results, the force, we added the force. Now, the given table, this one is the data and result. 30 grams plus 5 grams multiplied by 980 centimeter per second squared, we have 34,300 dynes. For the first trial, we got 1.4 seconds, the second 1.02, and the third trial is 1.10. You have to get for the average time, then the acceleration. Remember that the formula for the acceleration is force over the mass. Then, since the given here, tapos we have number 2, you have 55 grams, therefore plus 6 grams, we have 60 grams. Then get the force in dyne. Then the first trial, 1.3, 1, and 0.98. Get the average time again, then get the acceleration. Then 75 plus 580. Okay, remember that the formula for the acceleration, we have final minus initial over t, di ba? Pero we have also the formula of another formula for the acceleration. S is equal to VOT plus 1/2 AT squared. Since the initial velocity that I use during the activity is 0, therefore this one is 0. Now you have 2s is equal to AT squared. Now, in getting for the acceleration using the data given, you have the acceleration is equal to 2 times the distance or s over t squared. That is the reason we use a is equal to 2d over t squared. We have the constant value for the distance. I use 80 centimeter for the distance. Okay. Since the unit is of the acceleration should be in centimeter per second, okay, the distance would be in 80 centimeters.